Hey everybody, it's Troy. We're going to have a lecture today about networking and Windows 10. So, as I've told you before, this class is to prepare you for the next class, which is the Windows Server class. And this will be kind of a foundation, and then you'll be in the more advanced where you're working with servers. But before you do that, there are some things that you need to kind of understand and understand a little bit about. So the first thing I want to talk about is IP addresses, all right? So right now we're using a protocol called IPv4. And IPv4 is what you guys all recognize as addresses like 8.8.8.8 or 192.168.30.115. Those are IPv4 addresses. Now, the reality is that we have run out of IPv4 addresses. In fact, they ran out of them a long time ago. And they knew the day was coming, and they had to do something about it. So they did create a bridge, and we'll talk about that in just a few minutes. But for right now, we're just going to concentrate on the IPv4 address. And the IPv4 address is made up of octets. Now, the reason they call them octets is that each number in an IPv4 address is made up of octets, or binary, if you will. So that first 192, there is a corresponding sequence of ones and zeros that equal that 192. All right, and we'll go over binary a little bit later. But the important thing to remember is that that 192 dot whatever, each one of those are called octets, and they correspond to binary. And the reason they correspond and have binary is because computers have to dig down to the very base level, which is binary. That's what they speak. A computer really doesn't understand an IP address any more than it understands a URL, okay? It's just an easier way for us to assign numbers and names, because that's the way our brain works. But within a computer, it's going to break everything down to ones and zeros and then reassemble it again when it needs to. So when you have an IP address, and let's take a quick look at one real fast. Let me pull one up. Okay. All right, so right now, I'm showing you that I'm connected to the internet. It's the name of the network that I'm connected to, okay? We're gonna go in here real fast, because this is, you'll wanna get used to this change adapter settings, or options, because this is where you can go in and make changes to IP addresses or troubleshoot stuff. So, if you ever have to assign a machine a static IP address, then this is how you would do it. If you want to see what Subnet Mask you're using, this is how you could do it. So I'm just going to go in here and we'll pull this up real fast. Okay. So when you look at this, you'll see that there are spaces for all of this weird information to be put in. You know, it says IP address here, Subnet Mask, default gateway, my preferred DNS, and my alternate DNS. So that address I told you, 192.168.30.115, if that's the address to your computer, then it would go here. Now mine's not showing because it's set up on a DHCP, so it does all of this automatically. And that's good. That means that it always makes sure I have an IP address. The downside is that it's always changing. So you can end up with what we call name resolution issues. And that's covered in your reading. All of this is covered in your reading, but I just want to hit some points that are really important. Your subnet mask is what is it's I'm trying to figure out how to describe it. It's another 32-bit binary string, so it has octets, and it's used in identifying your unique identity. Okay, it's the host ID, and that lives in within the subnet, right? So your host ID or your unique ID would be the 192.168.30.115. The very last number on that particular class of email address is the host machine. Everything before that is what they call the identifier. Okay? As you read through your book, you're going to find that there's three. Well, we're going to only worry about three types of IP address classes. You have a class A, class B, and a class C. Most common is a class C. That's probably what you deal with. You may deal with B's and A's if you have a high number of IPv4 addresses that you need to use. The default gateway, that's how you get to the internet, okay? So that is that's where your machine goes to access the outside world. And then your DNS, the DNS is all about making sure that your computer knows where to go when it needs to be forwarded, or it needs to be identified, or whatever it needs. That's where it goes. So you have a primary, and you also have a secondary. The secondary is used like in corporate situations where you might have a redundant DNS server. All right. So that's what you see here, right? Now, like I said, if I were using just a computer that's static, all these numbers would already be filled out, okay? And if you're missing one of these sets of octets, except for this alternate, then your machine won't work the way it's supposed to. Okay. I've linked a video to subnetting that is it's in a different assignment category. It's called subnetting video. You need to watch that. He does the best job of explaining subnetting that I've really ever seen and how you do that. But basically, a subnet is a way that you can take a huge group of IP addresses. Let's do this real fast. Let's pull up. So when you have 192.168. Okay, so these 3 octets right here, that's my identifier. That identifies the network itself. It doesn't identify my machine yet, that's the network, okay? And then if I show this, that means that I have a complete range of IPv4 class C addresses. You're like, well, what does that mean? Well, kind of depends on who you're asking. If you're asking Cisco, if you're asking somebody else, although they're very close to the same. What it means is this: you have 192.168.50.0 through 192.168.50.255. So you have all of those addresses. Now, but you can't use all of those addresses. Okay? So you don't use the .0, and you don't use the .255. Those are reserved. So usable addresses, for all intents and purposes, is going to be 192.168.50.1 through .254. And those are the ones that can be assigned. And whether those are assigned statically, which means by hand, or DHCP, which means it's given to you automatically, it's leased to you. It doesn't matter. Those are the ones that you have available. Now, that is what's called a private IP address range, okay? Meaning it's non-routable. You cannot try and get to the internet using that IP address. The internet won't do anything with it. If you have a website, or you're going to a website, or whatever, it won't have a non-routable IP address. And so there are routable IP addresses and non-routable. So this 198 or this 192.168, when you see that, those are non-routable. And then there's also 172. I think it's 172.16. But I can check again. I don't know everything off the top of my head. And that's another non-routable, okay? So you have to use non-routable IP addresses when you're inside of a private network. So if you think of a network, you think of the firewall, all right? That's like the front door to your house. And inside your house, that's the private network. Once you walk out the front door, now you're in the public domain. So inside the house, you have to use certain IP addresses. Outside the house, you have to use other IP addresses. And there's a way that your computer knows how to translate that, okay? And it's called the NAT, and it's network address translation. And if you remember earlier, I said that there was a band-aid that they had created, or a bridge, for the fact that the IPv4 address has been used up. So what they did is they created NAT, which is the network address translation. And the network address translation basically is able to take your IP address when you're getting ready to leave your network, and it translates it or changes it into the IPv address that's going out. So you have a one-to-many. So a lot of companies will only have one IPv or IP address that's considered outside or routable, but they have a whole bunch of internal users. The internal users all use that same IP address, just because we don't have enough. The one thing that will happen eventually, I probably won't be around to see it, but they will be implementing IPv6, which is a totally different ball game. Instead of being a 32-bit address, it's 128, which means it has a lot of usable IP addresses. And just remember, everything that goes out on, everything that is attached to the internet, if it's your computer, tablet, laptop, smartwatch, smartphone, Internet of Things, all the stuff in your house, cameras, your refrigerator, your blinds, they all have to have IP addresses. All right? Okay. So, we talked just a little bit about subnetting, and so watch the video on subnetting. And subnetting is, in short terms, subnetting is a way to divide a network up so that you have more control over where those people and those addresses can go. Okay, and subnetting, a lot of people do it for different reasons. Even when I worked in the industry for 12 years, I didn't subnet anything because we never had to. Okay, we just didn't. We didn't have enough users to even worry about that. And we didn't. Our departments weren't very big, so we never did it. But it's important to understand the concept because it helps you understand how networking works as well. All right. So, like I was saying before, there's public and private routing. All right. So when you're doing your internal setup, right? You're creating your network and you're giving it IP addresses. There are certain ones you can use. For example, you can use the 192.168. All right. You can also use the 172.16 .0 through 172.16.31.255.255. Okay, so once you get to 172.32, now you're no longer in a privately routable, and then you can also use a 10. So you can use the 10.0s all the way up to 10.255.255.255. Okay, and those are, the 10 is a class A, the 172 is a class B, and then the 192 is a class C. So you'll find out what that means when you watch your subnetting video. Those classes become important to understand when you're doing subnetting, okay? Because that's going to determine if, say for example, you know how many hosts you need, then you can use your knowledge of subnetting and the IP classes to see which one do I need to use in order to get that X number of hosts that I've been told about. Okay? So one of the things you can do for practice is on your VM, you can go in there and mess around and like put in IP addresses to kind of get practice, and just make sure you're using the private ones when you're doing it, or else it'll just puke at you. But kind of work on that, get used to that a little bit. But it's really important to understand that that number that you're assigned to a computer is what DNS uses to figure out what the name of the computer is. So that's what DNS does, domain naming services, okay? It takes either the name of your computer, so say your computer's called T-Taylor L-1, all right? It takes that name and it matches it up to the IP address that it's assigned to. So if you were to enter that IP address internally, it knows that, oh, that's TTASM L1 or L-1. If you put in TTASM L-1, then it knows what your IP address is. One of the biggest problems that you'll encounter, when I say biggest, it's not the most complex, but it's probably the most common, is what's called name resolution. And a name resolution problem is when DNS gets itself into a state where it's confused. And it really, one of the ways it really manifests itself is if you have remote users and your users VPN into your network, and then they use remote desktop to get to their computer, right? Because they're working at home, they got COVID-19, they got to work at home, so they remote into they VPN into the network, and then they remote to their desktop, and they type in their computer name, TTASM L-1, and all of a sudden this message pops up that says, I don't recognize that, and then it'll give you 3 options that are usually completely useless, and it's Microsoft, but it'll give you options like, make sure maybe the computer is not turned on, maybe the computer is not part of this network, or maybe you spelled it wrong. So they blame you for all 3, when in reality what's happening is, and the way it's really simple to test this, basically DNS is no longer recognizing the relationship between the URL TTASM L-1 and the IP address that has been assigned to it. It's gotten itself all screwed up and confused. The easy way to know if it's a name resolution, that's right, I know you just guessed it, is instead of typing in the name of the computer, if you know the IP address, type in the IP address. And when you type in the IP address, it's going to take you to, it will all of a sudden recognize it. And I don't know how many times I had to solve that problem for people. It's very common. But just know that's what it is. And that's why DNS is so important. And it's why it's so important that you have a DNS listed in that little dialog box that I showed you. Because if you don't, then it has no way of knowing where to go to find out where it's supposed to send these messages. Because your computer itself doesn't really know. All it knows is, oh, Bobby wants to go to ESPN. Well, I don't know what the hell ESPN is. I don't even know what those numbers mean, but I do know somebody that knows. So it goes to your DNS server. And your DNS server, because it's internal, is going to say, I don't know what ESPN is, but I do know somebody that knows. Then it goes out into the public. And this process goes on until it finds somebody that knows what ESPN.com is. Who's not a communist. Everybody knows what ESPN is. And then you end up at the ESPN.com server, and you start communicating back and forth. And that's the other thing that these network address translations do. So think of it like this. Let me get good old Let's get good old paint up here, because I'm a master at art on these things. All right, so we'll get we better do something thin. Yeah, we'll do this. So here's your firewall. Okay, that's going to work for that, but that's really thick. Okay, so here's your firewall, and here's the outside world. We're just gonna, whoa, and this is in. Okay, so in here, this is where you're going to be doing the internal 192 stuff. Okay, this is ridiculous. You get what I mean? That's horrible. So we have inside, we have outside, okay? So now the issue is when you have your address here, oops, you know, whatever it is. Remember, this is not publicly routable. So what it does is it hits your networking equipment, and we'll learn about all that stuff later. I don't want to use too much to confuse everybody. It hits this, hits your DNS, and you ask it, how do I get to this this ESPN.com thing, right? So you want to go to ESPN.com, and it says okay, and here it's like, don't know what that is. Out here they do know what it is, okay? And so this person says, I know, and then it gives you whatever the address is. Okay? And so it goes out, but it goes out using that one or maybe a couple different ones of the publicly routable IP addresses that your company has. But remember, your address isn't that routable address. So how does it become the routable address? Well, that's where this network address translation comes into play. And by black magic, it can take your internal address and it changes to public. And the public address it changes to is all determined by what public addresses your company has paid for. That's why you have an ISP. They give you a public address. So it changes it to the public, and then it sends it out, and it hits that, it goes through the process of finding what you want, and then you want to see, and then ESPN shows up on your screen, and you want to see the scores for a baseball game. So you click on that, and then this whole process happens in reverse. You click on it, and it makes sure that you can get that information. And on its end, it's doing the exact same thing yours did. It's going from a private address through all of its stuff, through its firewall, and it hits your firewall, and it's like, hey, this is ESPN calling, and I've got a message for, and they give the one routable address your company has. Well, how's it going to know where to send it? Because everybody's using that. There's 60 people in your office. Everybody uses the same public IP address. How are we going to know where to send it? Well, that's the beauty of NAT, is that these transactions through the, and they can be understood once you dive into the OSI stack. But these transactions, it's remembered here that the person, that a specific request was made for ESPN. I'm just making, this is an oversimplification. It was made for ESPN. ESPN sent that information back, and now it hits your network, and your network goes, oh, I know who asked for that, and then it translates and it routes that message to the correct IP address inside, okay? And you can see why we ran out of IP addresses if you start to think if every single thing that connects to the internet had an IP address that could be routed publicly. That's why they ran out of them so quickly. Because, I mean, everything has IP addresses now. So, this is why we have all of these numbers and URLs and all this other stuff. It's to make this whole thing work, okay? And it's a really in detail process and protocol. I've made it sound really simple, but if you think about it, somebody sat down and thought all this up kind of on their own. And those guys were super smart that did this. And we have a World Wide Web, and you have to remember that we're sharing these IPv4 addresses in the world, not just in Utah or in the United States. It's in the world. So that's why they came up with IPv6, and you can read about that in your textbook. I'm not going to spend a lot of time on it yet, but let me see if I can pull one up for you. An IPv6 address is completely different than an IPv4. It looks totally different. Let's see if I can find one. Here we go. Nope. Sorry. Give me a second, I'll find you one. Compressed one. Sorry, hang on. Okay, so this is what an IPv6 address looks like. Totally different than IPv4, and lots more characters. They're using letters and numbers. So it just provides a huge range and possibilities for how many can be done. Now, it's going to take a long time to get switched over to IPv6 because most of the equipment that's out there right now, the networking equipment, only supports IPv4. So people are going to have to change all that equipment over, and then people are going to have to get used to these types of addresses. Because remember, in our first example of the regular IPv4, when you have the 192.168.30, you know that those first numbers is your unique identifier for your network. And then the last number That's your host. Even if you were to take a look at like a, let's say a class B, so you have 172.16. Now, maybe your company's super big and they have multiple offices. And so maybe what they do is they say, okay, so now we're going to make this third octet our office identifier. So maybe you have 30 for Florida, you have 40 for California, you have 50 for Utah. Okay? And then in each of those offices, you can do 1 through 254. Because, remember, and then dot, and then you also have dot 50, okay? So we know when we look at these that, we know which one. So in this one, just the first 2 octets are the network identifier. In this one, the first 3 octets are the network identifier. In this one, the first 2 are the identifier, and then the company decides what the third and fourth are going to be. What the third's going to be for. It could be a physical location. It could be a department. It could be a separate building or a separate floor. And then the last octet is always the host identifier, the machine that is attached to. Okay? Okay, so one of the other things that will happen on your machine, I'm sure a lot of you guys have heard of host files, and a host file is really kind of a cool thing because it contains your host name and the IP address, and so that it can get resolved through the resolver cache, and it makes things faster. And you can also cheat sometimes if there's a site you're having problems getting to, whatever. A lot of times you can drop that site into your host files and get it to work. So just something to keep in mind. But but DNS is a huge thing because it is what is going to continually make sure that your message and request is going to the right place and that the answers are going to the right place, okay? And that when you access your computer, you're accessing the correct one, not trying to get into somebody else's. So we'll stop with that for now. We'll pick up again as we continue to talk about networking, and we'll start talking, we're going to start getting into Active Directory and things like that. So should be fun. If you have any questions, if you were confused, make sure you read your textbook, go through, look at the examples they're giving you. They're really good. And I hope this helps, and I hope you guys have a great rest of your day.